Hi, my name is India, and my group will be presenting about retail analytics. In my group, I have Tanya, Shruti, Deja, and Vaishnavi. We will be talking specifically about retail analytics on Black Friday and what that market growth looks like in the future. So apparently for retail analytic market size from 2016 all the way up until 2024, it's expected that it'll grow 19%, focusing specifically on customer management, supply chain, strategy, and in-store operations. Why did we choose retail analytics? We chose retail analytics, one, because women love shopping. In addition to that, in Black Friday, it's the most popular shopping day of the year for all U.S. consumers, and it gives markets the chance to kind of understand what the customer retention rate will look like, the sales per square foot of that particular store, how to tailor products for sales, and the customer retention rate, amongst a few other things. For the Black Friday data set that we used, the problem statement was a retail company wants to understand the customer purchase behavior against various products of different categories. The solution to that problem that we identified was a model to predict the purchase amount of customers against various products, which will help them to create personalized offers for customers against different products. And how do we do this? We did this by dividing our factors into 4 different levels. So we have a city level, which focuses on urban cities or tier cities possibly having higher sales. Customer level, customers within a certain age bracket. So we would hypothesize customers between age of 25 and 40 would have higher sales. Product level, the target in most cases that we can hypothesize for Black Friday and has been a statistic in a while has been technological products. And then we have store level in a sense of where is the store located in the city with the highest sales growth.
Yeah, for explaining the problem statement, our data was huge. It has like 5.3 million rows. We did a detailed analysis of the data and came to know how various variables are related to each other. In the first graph, we can see that the age group within 26 to 35 was having the largest transaction count. Below, we can see the male were purchasing more. Here we can see the marital status was not a differentiating factor, and here we can see that the city in the suburban level was purchasing the most. Also, the occupation was not a very relevant factor because we couldn't identify a trend. Here we identified that the product category 10 was contributing the most in the purchases. The product category 10 denoted the clothing side, so that needs to be focused on. Here we can see that the purchase price within the group 6,000 to 9,000 had a very large count. And here these are not the very critical factors, but here we can see that where the people were staying for up to 1 year, they were purchasing the most. When preparing the data for the data analysis and modeling purpose, these are the fields that we worked on. We removed the user ID because it had unique values and it was not very critical, or it is a unique feature that cannot be modeled. So we removed that. For the age was in alphanumerical value, so we gave them a numerical value because model works better on the numerical value. In the city, there were 3 categories of city, so for those 3 categories we made 2 columns, city A and city B, and gave the binary value to them. And same process we followed for the stay in the current city. For gender also, we converted that into the binary value. For product category 2 and product category 3, there were a lot of missing values. So we replaced the missing values with the 0. And this is how we got our data ready for the modeling purpose. Now, thank you. I'd like to pass on to Desha.
Okay, so our first technique here, we're going to talk about linear regression. In our group, we focus on multiple regression, which is just an extension of linear regression. It is used when you want to predict the value of a variable based on the value of 2 or more other variables. And so our goal was we want to determine whether the purchasing price can be predicted based on the other independent variables such as gender, age, occupation, city, marital status, and etc. Now, in our data set, the independent variable was purchasing price, and our independent variable, like I mentioned before, were all those other headers. So let's go ahead and talk about the evaluation. How did we evaluate this technique? Well, we looked at R-squared. Now, to define that, R-squared is a statistical measure of how close the data are to the fitted regression. Now, what does that mean to us? Well, R-squared is usually between 0 and 100%. Now, 0% indicates that the model explains none of the variability of the response data around its means. And 100% indicates that the model explains all the variability of the response around its means. So, further to speak on that, in our data set, our R2 was 0.62%. So to elaborate on a little bit further here, what that means is you might assume that that is just a moment here, you might assume that the relationship between the model and the response variable is low. And in some situations, it is entirely expected that your R-squared value will be low. So for example, in any field that attempts to predict human behavior, such as psychology, typically your R-squared values are lower than 50%. Humans are specifically harder to predict, say, than physical processes. Our R2 could also be low to the sample size. Since our data set is relatively large data, there's a problem in generalizing the results, right? So in our observation that had a smaller sample size been used, it could have had a different impact on our R2. It could actually been a little bit higher as well. We're going to go ahead and move on to the next technique. Okay, so the other technique that we wanted to talk about is decision tree. So a decision tree, just to give you a definition, is a graph that uses a branching method to illustrate every possible outcome of a decision. So again, our goal was the same. We still want to look at our purchasing price to be a predictor of our gender, age, occupation, marital status. Now, our evaluation in regards to decision tree was that it was actually beneficial for us. Decision tree was actually performed poorer than regression tree, but it did offer more explainability, as the difference between the actual and the predicted values is not much. Our purchasing category 1, it contributed to the most predicting purchase price, and the decision tree and the regression don't have much difference in accuracy. Therefore, to assume more explainability, this decision tree was recommended. Okay, so our third technique we're going to talk about is clustering. So what is clustering? Clustering analysis is an exploratory analysis that tries to identify structures within the data set. In other words, clustering is a process of grouping data based on its similarities. So we can use clustering analysis to gain some valuable insights from our data, seeing what groups the data points fall into when we apply the clustering analysis. So let's go ahead and evaluate that data. Okay, so just to give you some information in regards to the evaluation of the data, the measure used to determine the quality of the model was predictive power. Predictive power is a model that is the quality indicator of the models generated when using the application. So in our data set, predictive power was 0.69. This means that 0.69 is capable of explaining 69% of the information contained in the target variable using the explanatory variables contained in the data set analyzed. So, in other words, 1 is a hypothetical perfect model. capable of explaining 100% of the target variable using the explanatory variables contained in the data set analyzed.
We wanted to try more techniques, but our data was really large, so we were very restricted with the tools. What we thought of is pulling off 10,000 rows so that we can test those techniques on these tools. We came up with a random sampling technique. We assigned random values to various rows and then selected the top 10,000 rows. So on that data, we performed three techniques. One is regression, the other is neural network, and the third one is genetic algorithm. In the regression, we got an R2 value of 0.62, which is quite close to what we got with our larger data. So we can say that this data is too representative of the whole population. In the neural network, we got a R2 of 0.04. This is because neural network doesn't go very well with the categorical variables. And with genetic algorithm, our R2 was 0.51 and our fitness measure was not very appropriate. So these are the results that we got with our sample data of 10,000 rows.